Mr. Allen here with part 2 of Math in the Wild with GeoCon. The other day, we went outside with the goal of proving that the side angle side congruence postulate actually works. Two groups were given the same 3 pieces of information to set up their own triangle. And in the end, they had nearly identical results for the 2 missing angles and the third side. In this video, we're going to actually calculate those 2 missing angles and that missing side using non-right triangle trig. The first side that we're going to solve for, or the only side that we're going to solve for, is this one right here, and we're going to label that with a lowercase b. All right, so for side lengths, we can use lowercase letters that are across from the vertex, which has the capital version of that letter. All right, so law of cosines is a big old scary formula. So it's going to be b squared equals my side, 80 squared, plus the other side, 60 squared, minus 2 times that first side, there's our multiplication, times that second side, and then times cosine of the included angle, that 110 degrees. So we're going to go ahead and plug that entire right-hand side into our TI-84 plus graphing calculator. As you see, I've already started to do here, and then I'm going to have a cosine of 110 degrees. All right, and we should get a big old number here. Boom. All right. Now, that's what b squared equals, right? That's what b squared equals. Well, how am I going to get it just b? I would need to take the square root of that. Now, either I can raise that to the 0.5, or I could square root and copy that number down. I prefer to do caret and then 0.5. That's raising to the 1/2, which is the equivalent of taking the square root. So if I do that, that is my missing side length. So we have 115.2536, so 115.25 feet. There we go. So 115.25. That's the final answer right there. But I'm actually going to keep this right here, that dot, 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 so I remember that value that is in my calculator, right? We want to calculate still with this with our unrounded value. So what I can actually do with my calculator here is I can store this value using this STO key. If I hit that, and I can choose a letter to store it for. How about B? Now, this one's actually going to auto do a capital letter, but hey, we'll roll with it, all right? Now, you could also use your arrows to copy a number down later on. Unfortunately, this calculator doesn't have that functionality, so I'm going to store it, all right? Now, the next thing we need to do to try and solve for our angles is what's called law of sines. All of law of sines is basically this big old super proportion where we take the sine of an angle over its side across from it. In this case, the sine of angle A would be over that 60 right there. And sine of B, which is 110, would be over this known side length. And then sine of C would be over that known side length there. So let's set that up. All right, so we've got all of our numbers in place here, and we actually have one fraction, all right, one ratio here that has numbers in both the sine as well as in its denominator. So we have to use that middle one to help us find the missing angles. Now, although it doesn't matter for this particular one, generally speaking, we want to solve for the largest angle that's missing. That's going to be across my largest side, which would be those two right there. We're going to solve for angle C first. The way I'm going to do that is with cross multiplication. So I will take 80 times sine of 110, 80 times sine of 110, and that'll be equal to that 115, which we've stored as B in our calculator, times sine of C. Okay, so now if I want to get sine of C alone, what do I need to do? Well, I'm going to divide by 115.253 dot, dot, dot on both sides. 115.253 dot, dot, dot. Boom. This whole mess needs to now be plugged into our calculator to get what is equal to sine of C. So let's do that. So I have it almost all plugged into my calculator here, and I'm going to divide by, and as we stored it was B. All right, let's do that. Boom. So now I have my fraction here. We have 180 times sine of 110. Make sure you double close that parentheses there, and then I divide by that 115. That's what I stored as B, right? Okay, perfect. If you have the fraction capabilities, this one does not, then you'd be in a little better shape. I got to be careful with those parentheses. Okay, so I get this 0.6522. Well, that's equal to sine of C. So if that equals sine of C, but I want to get C out of there, what do I need to do on both sides? Well, I would then take the sine inverse on each side. So in my calculator, I will go ahead and plug sine inverse of that 0.6522 and change, and that should give me my angle. So to get that pretty accurate number there, right? It's a lot of decimal places. It's not like it's not rounded. The calculator always rounds at the very end. But to get that whole decimal thing without typing it in, I can hit second, and then this very faint blue down there says ANS. That means answer. The previous answer will automatically be put in there, or if your calculator is able to, you can hit arrow up, highlight it, enter it in. Hit enter, and boom, I get 40.712 and change degrees. So that would be my angle C, but how am I going to find my other angle? I could go through that whole mess to find angle A again. Or what do we know about a triangle? Well, there's 180 degrees in a triangle, right? We already knew our given was 110 degrees, right? And then I could also subtract what I just found, that answer. So second, now that one, when I put ANS, that'll take that 40.7. If I hit enter, I get 29.28. So if we go to the nearest 10th, how about that? If we go to the nearest 10th, I have 40.7 and 29.3. 40.7 and 29.3 degrees for both of those. And we just go ahead and pop those on our answer lines. We can go ahead and see, oh man, those guys were super, super duper close. They were within like 0.2 of a degree, 0.3 of a degree, pending the group we're looking at. And then we had one group that was only a 1/4 foot off, right? And the other one was just over 2¼ feet off. That's pretty darn close for working on some unlevel ground out there with some tape measures, some transits, getting some angles of rotation. They're pretty darn close there. I think that was pretty cool. Those would be your more exact, precise answers by mathing it up. But we also were able to create it with those transits out in the wild. That's dope. That's application at its finest. You guys have a fantastic day. America, freedom, rock and roll, Costco, Riverdog Jenny on the gram. Yo-Ro, of course. Yo-Ro, of course. You guys have a wonderful day. I'll see you later.